Hello and welcome to Calculus 2 here at Cañada College. My name is Lapuz. In this video we'll be doing checkpoint 6.2 coming from section 6.1. They want us to sketch the graph of this function f of x is equal to 1 divided by 1 minus x squared, and then the corresponding partial sums. So these are the partial sums. So it looks like they did the partial sums for us. All we have to do is put different values for n up on the power thing. All right. So let's take a look at some partial sums to begin with. And let's see. For n is equal to 2, I think they only want to take a look at some even problems here. Let's take a look at the partial sums for n is equal to 2. So when n is equal to 2, we have the sum as n goes from 0 to 2 of x to the 2n. So we are going to put 0 in there, so x to the 0 is 1, and then we will put 1 in there, so this is going to be x squared, and then we're going to put 2 in there, and that will get us x to the 4th. Alright, not so bad. This is going to be the second partial sum. I suppose we should label this as s sub 2 of x. That's the n that we have. And then we'll try n is equal to 4. This is s sub 4 of x. This is going to be the sum going from 0 to 4 of x to the 2n. And this will give us when x is 0, when x is 1, when x is 2, and then will give us when x is 3. This is going to be 3 times 2 is 6, that's x to the 6th. And then when x is 4, 2 times 4 is 8. So it's not a coincidence. Notice that the first few parts or terms of this partial sum will mimic the others, and then so we'll just add on more terms as needed. Alright, finally let's do n is equal to 6. S sub 6 of x will be equal to the sum as little n goes from 0 to 6. And again, this is going to be the first term, the second term, the third term, or 0th term, the first term, the second term, the third term, the fourth term. And then we got 2 more terms, 5 and 6. So the fifth term, oops, I forgot, sorry, to include x to the 2 to the n, because that's our sequence that we're working with. So when n is equal to 5, this is going to be x to the 10th. When n is equal to 6, this is going to be x to the 12th. Alright, so these are your functions, and then let's just use a graphing program to do that. Here I have Desmos, and this is the graph of 1 over 1 minus x squared. Now we only want to graph this from 0 to 1, and so this is all we have. It does make sense because that looks like it's going to be the radius of convergence is 1, and the interval of a convergence is going to be, well, technically it goes from -1 less than x less than +1. So that's the interval of convergence. We don't want to include the positive and -1, so we don't want to have that equal sign there because, well, it goes off to infinity, so it's going to be undefined. Alright, now I can type in the 1 plus x squared plus x to the 4th here and get a good look at that graph, and maybe a closer look will get us there. But instead of doing that, I'm actually going to take advantage of some of the features that Desmos has. So if you type sum for sum, you get the sum, and I want the sum from 0 to some number. So we'll start with 2 because that's what they asked us to do. And then our function here is going to be x raised to the 2n power. And this is going to give us the exact same graph as the graph that we have here. Okay, so I could just do this instead of typing in a whole bunch of other pieces of the graph, and then copy that down here. Whoops, that's not what I want copied. I want this copied, and then change this into 4. And then now, if you could take a look at the green graph and then the purple graph, you could see that the graph, the original graph over here is a little bit wide, and then the purple graph kind of starts to hug the original graph a little bit more. It gets closer and closer. And so that's the whole point in adding more terms to our series, is that it's going to mimic the graph more and more within the interval of convergence. And so instead of doing the third one, what I'd like to do instead is maybe create a slider here and call this a slider for A. And then we'll have A go from, I think we started at 2, and then to 6, and then let's go in steps of 2 so that we're looking at whole numbers. All right, so let's take a look at this, and let's take our next step. So from 2, and this is 4, it gets closer, and then one more, it gets closer still. Now we are not going to probably see this thing mimic it exactly, but it looks awfully close to the graph, which is again the whole point in these power series, to say that the power series converges to this graph. If we zoom in somewhere over here, we could see that there's still space between there, and if we zoom in really a lot, you can see the spaces between the graphs. But if we zoom out, we could see that it looks like it mimics it pretty well. And then now, because we have the slider, I can make it go up to 20 or something kind of ridiculous, and then see it get closer and closer. So we could see this 2, we'll take a step, it was 4, 5, 6, 7, 8, or I mean 12, 14, 16, 18, and let's zoom in on one of these points over here, and you can barely see the difference now between the red graph, or I'm sorry, the original graph in black versus the green graph in what we're looking at. Okay, so that's the idea behind these things, and if you do want to see all the graphs, you can certainly copy and paste this. Let's get rid of this and just go back to the graphs, and instead of A, let's put the actual numbers there. I think the first one was 2, and let's take a look at what happens when this is 4, and then another one when this is 6. Okay, so you can see the progression here with different colors as it gets closer and closer to the original graph. All right, that's it. I hope that helps, and good luck.